just stopped and wondered how an AI can write a poem, translate a language, or even code an entire app? Well, the secret behind all that magic is a really powerful idea called the transformer. So today, we're going to pull back the curtain and see exactly how this thing works. Okay, so let's kick things off with the big question that I'm sure is on your mind. When you type a prompt into an AI, how does it actually get what you're saying? You know, it feels like magic, right? But it's actually this incredible process of turning your words into numbers and giving the AI a very special kind of memory. All right, first things first, we've got a fundamental problem to solve. Computers don't speak English, or any human language for that matter. They speak math. So our very first challenge is to figure out how to translate our language into something a machine can actually understand and work with. And it turns out this whole translation thing happens in two pretty straightforward steps. First, we take the text and we chop it up into smaller pieces, and these are called tokens. Then, for each of those little tokens, we convert it into a special list of numbers that represents its meaning. And that list of numbers has a name. It's called an embedding. Now, you might think, okay, chopping up text, how hard can that be? But it's actually a bit tricky. As you can see here, there are different ways to go about it, and each one has its own trade-offs. You could break it down word by word, which is simple, but what do you do with new words the model's never seen? Or you could go letter by letter, which is great for catching typos, but it makes the text sequences incredibly long and slow to process. And that's why most modern AIs use this clever in-between approach called subword tokenization. It's the best of both worlds. All right, so we've got our tokens. Now, how do we turn them into numbers that actually mean something? I mean, we could just give each token a unique ID number, but that's a terrible idea. That would be like saying the words soft and teddy bear have absolutely nothing in common. The real goal is to create these embeddings, where words with similar meanings are actually represented by similar sets of numbers. I want you to imagine a giant, multi-dimensional map of meaning. Every single word has its own coordinates on this map. So on this map, words like king and queen would be really close neighbors, and Paris would be right next to France. That's exactly what a word embedding is. And here's the wild part. The AI learns to draw this entire map all by itself, just by reading massive, massive amounts of text from the internet. So we've given our words numerical meaning. That's a huge step. But what about the order they're in? Think about it. Dog bites man is just another Tuesday, but man bites dog, now that's a headline. The order of the words, the context, changes everything. So how in the world do we teach an AI to understand that? And that question, well, that brings us to this massive wall that early AI models kept running into. For years, teaching a machine to really grasp context was a huge challenge. It's kind of like trying to understand a whole conversation by only listening to one word at a time, with no memory of what came before. The first real crack at solving this was something called a recurrent neural network, or an RNN for short. Think of it like how you read a book. You read one word, then the next, and all the while you're trying to keep a running summary of the story in your head. That little mental summary is what the AI world calls a hidden state. But you know how it is when you're reading a really, really long book, right? By the time you get to the final chapter, you might have forgotten some of those little details from the very beginning. Well, RNNs had the exact same problem. They basically had short-term memory, and crucial information from the start of a long sentence would just fade away. At its core, the problem was that the AI just couldn't easily connect the end of a long paragraph back to something important at the beginning. It was like trying to remember the very first word of this explainer right now. That memory problem was a massive roadblock holding AI back. So how did we finally smash through that memory barrier? We did it with a truly groundbreaking idea called attention. And believe me, this was an absolute game changer. This slide just shows the difference perfectly. The old way, the RNN, is like a chain. Information has to be passed from one link to the next, and it gets weaker with every step. But with attention, it's like a web. Every single word has a direct connection to every other word. There's no more waiting, no more information loss. It's instant. This incredible new superpower is called self-attention. What it does is it gives the AI the ability to look at any single word in a sentence and instantly calculate how important every other word in that sentence is to it. It's like giving the AI a perfect, flawless memory and the ability to see all the hidden connections at once. So how does this actually work under the hood? Well, imagine you're at a crowded party. You are a query, and you're looking around asking, who here is relevant to me? Everyone else at the party is a key, and they're all holding up a little sign that describes what they're all about. You scan the room, find the keys that are most relevant to your query, and you grab a bit of information, a value from each of them. That's attention in a nutshell. Now, this whole attention thing wasn't just some cool new feature. Nope. It was the powerful engine at the core of a completely new kind of AI, an architecture that was about to change the world. The year is 2017. A team of researchers at Google publishes a paper with a title that sounds more like a rock anthem than a research paper. Attention is all you need. And with that single paper, the world was introduced to the transformer. So what exactly is a transformer? Well, you can think of it kind of like an expert translator. It has two main parts. First, there's the encoder. Its job is to read your text and build a really deep, context-rich understanding of what you mean. Then, the decoder takes that deep understanding and uses it to generate the output, like the answer to your question. And the rest, as they say, is history. Things just completely exploded. The transformer didn't just stay a theory. It became the fundamental blueprint for all the major AI models you hear about today, from BERT to GPT. Seriously, every single time you use a modern AI tool, you are witnessing the power of the transformer architecture in action. And that right there, that's the key takeaway from all of this. By finally solving that pesky memory problem, the transformer, powered by attention, basically unlocked the floodgates. It allowed us to train models on a scale we could have never dreamed of before. We could train them on pretty much the entire internet. All that knowledge, all those patterns, all that context, that is what makes today's AI so incredibly powerful. So the transformer and its attention mechanism solved the memory problem. It was a monumental leap. But it leaves you wondering, doesn't it? What's the next big roadblock for AI? What is the next attention breakthrough that's going to unlock a whole new level of intelligence and change everything all over again? That is the billion-dollar question that researchers all over the world are desperately trying to answer right now.